It
the more
started.
icon.
I think
Creo
it
que
started.
Okay, yeah. The recording is starting.
Yes.
Yes, thank you.
Okay, so I
Okay.
continue. Okay, we will see the important machine terms. So we will learn together what we call each part, each important part. We are not going through all the parts, but the main important ones. Then we will see the control and operations for the machine, how to make a new program, how to see and compare the nominal values and all these things. This is the plan for today. I hope that we can finish all, or maybe we can continue the control and operation part tomorrow. Then the second day will be, I will be focusing on the welding, so to see the important things, how we can make a good welding on the machine, and we'll give you some mechanical tips. I think the operator will benefit from that, and the also maintenance. And then what are the typical mistakes that we face usually with our customers? And then when you have some questions, general questions on the machine or something special, we can also discuss it together. Okay, so now I wanted to ask some question just to know a little bit the background. So how long do you work with Titan? Okay, I mean here, okay, maybe someone is new. He has never worked with our MBK machine, and maybe you are all okay with some parts, or you have already worked with this machine. Does anyone completely new, didn't see this machine, or everybody is okay with what he's seeing? I expect an answer here.
He's we have one new person right here.
Yes, okay. So yeah, welcome to the Titan group. Okay, so I
We
think
have another person that's new.
okay.
And Ricardo. So three people are new. Three
Three new.
people are
Okay,
new.
so it will be good. So they will learn some important things. Great. So let me now just give you a quick view on MBK. So we are a German manufacturing company, as you know, I think. We are active in the concrete industry. We make mainly reinforcement cages or reinforcement metal for the concrete. We have a mesh welding machine. We do this form. I think you see now. So this is mesh. It is used for ready or ready-made walls. We have also the cage welding machine. One of them you have, which can make round cages. We can also make rectangular, square cages, oval cages, or roar cages. Roar means round, oval, round in one cage. So these are some options. We do also truss welding machines. So you see this, I think you saw these things in some places. And we have also wire straightening machines. So we take some wires from a coil, we make it straight, we cut it to the length which is needed by the machine or by the end customer. Okay, so now we will move to Titan machine. I tried to get a 3D machine view similar to your machine. This could be not perfectly your machine because your machine is so old, so I didn't find a 3D drawing for it. But it's mainly the same. So we have the main wheel. This is the main wheel of the machine. This is, we call it also the heart of the machine. So everything, all the position will be regulated due or according to this main wheel. We have the feed wheel. This is what we call the feed wheel. This is the wheel only. And we have on the machine the feed drive or feed axis. So you can read feed axis on the screen, but normally we call it also feed drive. This drive is responsible to pull the cage when during production. We have the welding carriage. This is all the welding carriage. We have the expanding cylinder. This is responsible to change the diameter on the cages. And we have the control panel where you can control the machine from here. Okay, on your machine, you have a cage removal device. This device is manual, but we can also have some options with automatic. Here we have the water cooler and then the decoiler. So these are the main parts of the machine. I think you already all saw them on the machine and you know them well. Okay, we have to agree also on some movement direction. So when we say, let's say feed drive forward, so the feed drive should be moving in this direction. Because normally we face some issues when we talk to people, they say it doesn't go back, it doesn't go close. So now these are what we use normally for our machine. So forward means during production, so in the positive direction of the production. Feed drive reverse, it's when the feed drive return to the initial position here. Then we have the expanding cylinder. This cylinder here is hydraulic, but when it moves to this direction, that means the diameter will be increased. And when it moves to the other direction, means that the diameter should be decreasing. So expand and setback. These are the two words that we use for our machine. We use the same term for the welding carriage. So welding carriage expand means it moves to this direction. It is compatible with the increasing of diameter. So when the welding carriage expand, it means that the diameter is also expanding if you move both expanding cylinder and welding carriage together. Also, so welding carriage setback is the same with expanding cylinder setback. So the diameter will be moving to a smaller one. These are the most important direction that we have to agree on together. The coil or the decoiler will turn always in the same direction, which is the production direction. So this is not a big deal. So what are the main important mechanical things on the main wheel? So we see here the main wheel. This main wheel is composed of many mechanical items. We have a spoke, so each metallic welded to this side and to the center is a spoke. So this wheel has, I think, 36 spoke, and your machine as well. This is a slider. Here you can see also how it looks like. This is where you put the welding angle. We will see the welding angle now. So this is the welding angle. It looks like this. When anyone has a question, just let me know. And this is the wire guide. So all this part.
We do have a question, sir.
Yes.
I have a question.
Yeah.
In the welding angle,
Mm-hmm.
we establish the parameters. Well, we establish the parameter as or the times that welding should take. Do we establish the times that this welding should take?
Yes, but okay, now we are going to talk about this point. This you want to ask about the control, right? Of the welding.
Yes.
Yes, okay. We will now we are talking about the mechanical parts only, but we will also talk about the other point in the coming. So in the control and operators, we will see all the control thing for the welding and for other things as well. Okay.
Perfect.
Okay. So yeah, but now I just want to make sure that the new operators also know what we are talking about. So this is why when they see this part, they know that this is the welding angle. When they see this part, they know that this is a wire guide. Okay. Uh, I think they already saw it on the machine. If they are not, they didn't join today, but I think they already saw it. But now they know the name. Okay, the welding angle is composed from two main blocks. This block here is the collector. So, and this is here where the welding is happening. Okay, and okay, for the slider also we have two types of slider. We will see it here. Okay, so for the main wheel, these are the main mechanical parts, and to set the mechanical zero reference of the main wheel, it is important to know this. You have on the machine two type of slider. One long slider, it looks like this, and one short slider, it looks like this. So on the long one, you have three position where you can put the welding angle. You can put the welding angle on position 1, on position 2, on position 3. And on the short one, you have only two position, which is position 2 and position 3. So the long ones are used to make the smallest diameter of the machine, and the short one can be used with bigger diameter only. Okay, to make the zero mechanical reference, it is important to put a water level or spirit level on the spoke. So not on the slider, it should be put on the spoke itself. And then when the level is okay, you can see it by your eyes, then it will be the zero mechanical reference. Then you go to the control panel and you say, okay, this is the 0 point. So the procedure, we will see it in the control when we go to the main screen and we see how we can set this electronically. But mechanically, it should be like this. Okay, is this point clear? Is this point?
Yes, we'll expand upon it later on, but yes, it's clear for now.
Yes, okay. So the mechanical zero position, important to be on the long, on the spoke, which has the long slider, and then how to set it electronically, we will see it in the next slides. Okay, and the second important point to set on the main wheel is the diameter. So the diameter is measured between two opposite welding angles. So we take this point from the copper point, this here. I'm not sure if it is clear for you all. From this point to that point. So these are diametrically opposite welding angle. We take the measure here. So this will be the actual measure of the cage from inside to inside. Okay. And then this measure we can put it then after that in the machine to make the reference. We will see how also. So now we move to the feed drive. The feed drive is composed of the feed wheel. This is feed drive plus feed wheel. So what is important now is feed wheel. This is the wheel. This is the clamps. These clamps will hold the longitudinal wires together, or to hold the longitudinal wires and then to pull them when the machine moves. We have the feed drive. This is the motor for the drive, and this is the feed drive, which moves horizontally. And the same mechanical thing should be applied here. What I mean is that the long clamp should be in front of the long slider. This is a rule. In your case, you don't have a problem because you don't have separate motor for the feed wheel. It is related with the main wheel by a shaft. I see that.
One second,
someone
yes, a
has
question. I have a question, yes.
Mhm.
This is the mobile wheel. And this is where we actually take these clamps and this is what we call the engine for the mobile wheel. I just wanted to have all my operators to have it clear.
Okay, so this is not a question. This is only a clarification.
Yeah, it was only a clarification, no question.
Okay, okay. Okay. So yeah, what is important when you, I don't know, when you change this or when you do any maintenance and you need to remove this mechanical shaft. So it is important to put back the long clamp in front of the long slider spoke. So should be always mechanically the same position together. Now we move to the welding carriage. Okay, this is the welding carriage. It has the welding transformer, then the contact roller. This contact roller will be in contact with the welding angle. I can maybe so just for the new operators. So you see the welding angles mounted on the main wheel. Okay, and this is the, you see my mouse, right?
Yes,
So this is this is the contact roller. This is the welding roller. So this contact roller should be in contact with this part of the welding angle. And the welding roller will be in contact with the wire, which is at this place, will be at this place. Okay. This is just a quick information for the new operator. So we have the contact roller. We have the welding roller. We have, this is mechanically the maximum position for the welding angle. For this, sorry, for the welding carriage. For the welding carriage, we don't set normally the minimum position, we set the maximum position.
1 second, sir. We have a little noise with this.
Yeah.
Just give a second. ¿Qué escuchan bien? Yeah. Okay. Yes, we had a little interference with the radios, but now no more interference. Please go ahead.
Okay. So I just
No,
repeat
no.
this
1 second.
point.
1 second. See? Yes, just repeat that last point. Clear.
Okay. Is it now better? Okay.
Yes, we're good. We're good.
Okay.
We're good.
So this is the contact roller I was saying, and then this is the welding roller. This is the mechanical maximum position. I was saying here that the welding carriage, we don't set the minimum position, we set the maximum position. Normally, the minimum position is the minimum diameter that can be done on the machine. For that, we set the maximum position, and the maximum is normally 3 centimeter away from the mechanical stop of the welding carriage. Okay, and on this pistons we have analog sensors. These sensors can be read by the machine, and you can also read how much gap or how much uh, contact, if you want, you have with the welding roller and the contact roller. We will see this point in more details after that. Any question?
No question, sir.
No question. Okay. Now we move to the spreading cylinder. This is an hydraulic cylinder. So this is the expanding cylinder. This is responsible to move the sliders on the main wheel. By moving the sliders, we move the diameter. So this can work before we start the cage. So when you do 1 diameter, and it will never change. And when you do a cage with a bell or a little curve at the beginning or at the end, it can work also during production. We have the hydraulic unit, which control the flow of the hydraulic oil here, and it is connected to the cylinder. We have the wire encoder, which is an important encoder to measure the diameter of the cage. So using this encoder, we can see it here. We can see it here also in more details. We can see the wire also. So it will move here right and left with the movement of the cylinder. Then we can detect the diameter of the cage. We have the water recooler. This is used to cool down the welding roller, the contact roller, the transformer, the thyristor plate. So everything is related with welding, so they don't get hot and be destroyed. We have also the decoiler. I think everyone knows the shape of the decoiler. What is important for the spreading cylinder, we have here the chains. And these chains are connected to the sliders. So each chain is connected to one slider. And when the expanding cylinder moves, all the sliders will move together in one direction or the other direction. What is here important, that if these chains are not well or not same tightness approximately, then you can have some problems with the diameter or the welding. So it is important to control here from time to time that all the chains are tight approximately the same way. So there is no measuring tool to use it, but just from touching, maybe you can see how much they are tight or something like that. So this is how we do it. So when one is loose, it could be that you have one bad welding on one wire. So it's always when you make a cage and you see that, okay, always on this point or on this longitudinal wire, you have a weak point or weak weldings. So okay, you can say maybe the chain is loose, is a little bit loose. So you can check the chain. Sometimes something else can be a problem, which is the setup of the mechanical setup of the chain. Okay, I will try
We have a
here.
question, sir.
Yeah.
How do we know when the chain is tight and when it's not working, when the chain is not working? How can we know when the chain is not working?
It's not working, cannot be. So even the chain is broken or is not. So, but if it is loose, then you can see that from a difference in diameter or bed welding. So mainly when you have bed welding only on one longitudinal wire. So you know, okay, maybe it could be a reason that a chain is loose. I will just continue, and maybe this point will be clarified for some people. So okay, you see here we have the spokes, we have the sliders, okay, and we have the welding roller in this picture. And so normally how we make the setup for the welding or for the sliders to get a perfect round cage. You see here, so first we have to make sure that all the chains are tight. Then what we do is we make expand maybe until we reach this point, approximately. This is just an example. And then we measure the distance between the welding roller and the welding angle. So the welding angle at this point. Maybe I can put the 3D, then you can see better. So what we do is to measure the point between this here, this part here. You saw it?
Yes, we see it.
Yeah, and this roller. So the steps are as follows. We measure this distance. It should be, let's say it is 10 centimeter. Then you know that you have an option on the a machine where you can do main drive inching. So when you do main drive inching, the main wheel will move to the next welding angle. So the main wheel will move to this direction, up. Then you measure the second one, the second welding angle, how much distance you have. If you have 10 centimeter plus or minus 1 millimeter, this is okay. If you have 10.5 centimeter, then okay, this is not okay. You have to go to the chain to this point and then regulate the slider to reach 10 centimeter on the welding angle. Is it clear?
No, it's not too clear. Could you please review that part once again?
Yes. We control that all the chains are tight. Then we go to just 1 second. Then we go here to this side.
We have a question. How technically, how do we verify that all the chains are really tight? How do we verify technically? How can, like, what strategy do you have to verify technically?
It is a feeling. So you tight. It should be not. It shouldn't be so tight. But when you touch the chain, you can feel that if it is loose or it is tight. So when all has the same feeling, so approximately, it's not. It shouldn't be 100%. It's just a feeling. A mechanical guy will feel it. So this is how we do it. So we don't have any measuring tool or something. We just feel it when it is okay. So we do all together the same way. So from feeling, we say, okay, this is now okay. Then we move to this part. We expand. We make the diameter bigger, or until we reach approximately a measured, an easy to measure distance between the welding roller and the welding angle. This is how we do it. So when we measure here, let's say, I don't know, 10 centimeter, I just gave an example. When we measure here 10 centimeter on the first one, then we turn the wheel to the next spoke. We use the function main drive inching. We will see this after. Then the machine will move to the second welding
Could you
angle.
please explain function main drive inching?
Yes. Just give me 1 second. So you see, this is the control panel button. On this is on the control panel. You have these buttons. One of them is main drive inching. Okay, you see here you have another button adjusting on off. But okay, this now maybe we are passing some steps, but it's okay. So adjusting should be on, and then he can, when you push this button, then the main wheel will move to the next welding angle automatically. So it will automatically move and will stop when it reaches the second welding angle. Is it clear now?
Okay, great.
This is
Yes,
the only what you have to do. Only thing what you have to do. Yeah, I will go back. So here what we do, we measure 10 centimeter on the first one. We move by main drive inching to the next one. If it is more, the difference is more than 1 millimeter, we take, okay, we say that the tolerance is plus or minus 1 millimeter is okay. So when it is 10.5, then we have to mechanically adjust the slider from here, from this point. Okay, I use laser from this point. This you can move up and down. So the slider will move up and down from this screw here. Then you put it to 10 centimeter and you tighten it and done. Then you move to the second one
Okay,
until
question.
you finish the turn. Yes.
Yes, question. More or less, the tolerance is 1 millimeter. We just wanted to.
Yes.
¿Qué le pregunto? Okay. No. Okay, just let's, in this specific point, just let's go over it very slowly in this specific point because they're really interested in this point.
Yeah.
Okay.
Yeah, should I repeat?
Yes. Do you need us to repeat or is it clear? Yes. Could you please repeat that part too?
Yes, okay. So I will repeat from, okay, the chains are tight. This is clear for everybody, right?
Yes, that part is clear. That part is
okay. So now we move to this part when the chains are tight, everything is okay. We go to the welding angle side. I will put the 3D as well so the people will see it maybe better. Okay, this is the machine. So I made sure that the chains from the back side here are okay. Then, okay, everything's okay. I move here. Then I measure the distance between this part here and the welding angle. So I try to zoom a little bit in. Yeah. So I make the measure between this and this. So the welding angle at this point and this welding roller. If I measure here, I don't know, I say 15 centimeter. And then I go out here, I press reset and main drive inching. The wheel will turn to the next one. So first it was this welding angle, the main wheel will turn and you will have this welding angle in front of the welding roller. Then I measure again. If I have, okay, the first measure was 15 centimeters, so this is my reference, is 15 centimeter. If I see that this measure now is 16 centimeters, so I know, okay, I have 1 centimeter difference, I have to regulate. I have to mechanically adjust the slider. I don't know, maybe more, a little bit more here or there. This, you know, maybe if you measure 14 centimeter, then you have to push it to the other side. Then if you need to push it to the other side, you go to this side, maybe another person will be from the other side and the one will be on the welding angle side. And then I go to these two screws. You see them? These two. You tight them, you release them, and you move the slider how you want. These two, this one and this one. And then you tight them again when you reach the 15 centimeter. Okay. Is it clear now, or I have to repeat
Yes,
something?
clear.
Okay.
No, it's clear.
So in this case, you do the same operation for all the welding angles, and then you should have a good or a perfectly rounded cage when you produce. Okay.
What? 1 second, sir. Our computer is running out of battery, so we're running to connect it. So just 10 seconds.
Yes,
They're
yes,
connecting it
yes.
right
Okay.
now. It just said
This
it
this
says
is not a
connect
problem.
now. Okay, connected. So we're fine again.
Okay. So now this is some mechanical things, but these are very important to start. So once is well set up and these things are good, so the chain is tight, these sliders have the same, or the welding angles has the same distance from the welding roller, then the production will be easier because you know that these things mechanically are good. So when you have a problem, you know that this is not coming from here, maybe from something else. Sometimes the problem could be coming from the copper itself. So when you have too much dirt or the copper is not well cleaned, you know, after some production, you will have some residue on the welding roller, maybe on the welding angle, also a little bit some dust and some things. So you have to clean them to always have or to get the best results from the machine.
Question.
Yes.
Come on. Can you please show us the couple here on the 3D or there?
Sorry.
Where's the couple? Can you please tell us where the couple is? The coupling.
Yes. Yes, okay, okay, this is the welding angle. I can also so this is the welding angle. This is how it looks like. So this is a copper, this copper, and this is copper. So all these green parts are copper, what I selected. The wire goes
Perfect.
from here. So from this side, goes here, and it will be out from this side, from here. So this is the longitudinal wire, I mean. Okay. So the longitudinal wire comes out from here, and then the winding wire will come over it. So when we weld, the current will flow from the welding roller. Oh, sorry. Yeah, the current will flow from the welding roller through the wires. Yeah, you have here the longitudinal wire, and then it will come the winding wire, and through the copper. So the copper will
Question, sir.
this
One question, sir. That you have to do, that you need to do to the welding
sorry,
couplers.
I'm not listening. I'm not listening.
Okay. Oh, sorry.
But okay, you can
the
maybe he
cleaning
can
that you
ask
have to
the
do to
question.
the welding couples. Yes. The question is how frequently should you clean the welding couples, and for how many after how many hours? How do you do maintenance to the welding couples? How many
Okay,
hours?
normally it depends. This you can see when you have too much dirt, because I think the residues from the wire will be stuck here and here and here when it is too much, and then you have to clean it. When you see that the copper color is black, then this is not anymore good. So it is not. You need to clean it with the uh, not a sand not sandpaper, but yeah, it's like sandpaper, but this is for the copper. I will try maybe tomorrow to get you some picture for bed copper we got from our customers. I try to get you something so you can see it. Is that okay?
Yes. Clear.
Okay. So okay, is it clear how it works? So we have here so if you look at it from this side, so you see how the contact should be. So this is a contact roller. Here is a contact roller. It should be in contact with this part of the welding angle. And this is a welding roller. It should be in contact with the wire when you put the wire here in. So it should be in contact with this. And then the current will flow through the wire and come back here. So this is how the welding is done. So if you have bad contact here, or too much dirt on this part, or on this part, or you have bad contact between this part and that part, or between this part and the wires here, then this also can cause bad welding. Is it clear? or if someone has any question.
Nope, no questions so far.
Okay, great. So okay, this is the feed wheel. The feed wheel, as I told you, this you have here the clamps. You can see it also on the 3D. So these clamps will come close here, and then when you put the wires inside, then the clamps will close and then will hold all the longitudinal wires. And during production, this feed drive will move on this rail, and then it will move all the longitudinal wires together while this wheel is turning. So you get the cage done. This is how this is the principle of work of a cage or of this machine. Okay.
Okay.
So now we can move to the control. So as you know, you have the main control of the machine is outside, as we saw here. So this is the control. This is the control desk. This is where you can do everything. Okay, here, okay, you have clamping device open close. I will go one by one, I think, because this is important. Sometimes it's difficult when we say to the customer, okay, open the clamps, and then he say how we can open the clamps. Okay, normally these things should be very easy. So clamp open, close. So by this, using this button, you can open and close the clamps. When something you don't understand here or any description is not clear for you, I can directly show it to you on the machine mechanically. We have here electrodes open, close. Okay, electrode open, close. I will directly show you to the new, this is for the new operator. Okay, what we call also electrodes are these two, because these are the electrodes for the transformer. So here, this is a transformer, and it is connected to the welding and to the contact roller. So these two, we call them electrodes. And these two are open and closed by this cylinder. For the welding, you have one cylinder, and from the other side, we can see the other cylinder for the contact roller. So these are the electrodes. When it is closed, so the closed direction is when the welding is in contact. So it's going to the center of the machine. This is closed. So it's closed together with the welding angle. This is electrodes are closed. Open means they are open. The piston is completely back. So this is back. Is it clear for everyone? Open and close, because yeah, sometimes it could be a close. It means that this is back, but no, close. It means that in the direction of the welding angle.
Clear.
Okay. Here you have welding pulse. Okay, here you can independently from automatic cycle or anything, you can just, when you push on it, the machine will make one welding. So it will weld. So it will give the order to the thyristor to work and to weld one wire. This you can use it maybe when something went wrong or during automatic production and you need to continue and then you need to make sure that the welding is done. Then you use this button to to weld. Then we have here automatic start. When you press this button and automatic is on, then this light will be on. Stop is stop. You stop the machine in normal condition, so not emergency. So the machine will complete a cycle or and then stop. So it is a normal function of stop. Main drive inching, we have talked about it. So when you need to move the main drive inching has two functions. When adjusting is on and you press on main drive inching, then the wheel will move to the second, automatically to the second welding angle. In case adjusting is off, so the light here is off. When you press main drive inching, the wheel will turn as long as you press on this button. When you remove your hand, the wheel will stop. When you push again, it will start and will continue turning until you remove your hand. So these are the two functions that can be used with main drive inching. But it's all related to adjusting. I think here I will repeat this just for everybody's info. Adjusting on, main drive inching. So the main wheel will move a step to the second welding angle. Adjusting off. When we press on this button, the main wheel will turn until we remove our hand. Is it clear for everybody?
Yes, sir, it's clear.
Okay. If I'm too fast, or just let me know. We have feed drive forward. So the feed drive will move forward. I think everybody now knows to which direction, right? And when we say feed drive reverse, so the feed drive will move in the reverse direction. And now everybody knows to which direction, so to the main wheel. And this button also is depending on the adjusting. So when adjusting is on and we press feed drive forward, then the feed drive will move as long as we press on the button. If adjusting is off, then when we press on feed drive forward, it will move to the maximum position.
When adjusting is on, sorry?
Is on and we press on the feed drive forward, then the feed drive will move until as long as we are pressing on the button. When it is off, it will move automatically to the maximum position. Feed drive reverse is the same function with adjusting. Okay, clear for everybody? I
Yes,
like to
clear.
hear a little bit your okay, so I know that I'm still okay with you. Yeah, okay, here we
We're
have
okay.
the lights. The light is okay. This is automatic start when it is on, so the machine is in automatic. This is some common things. So when we make main drive inching during the wheel, when the wheel is moving, the light will be on. Feed drive forward and reverse the same when the drive is moving, so the lights will be on, and then when it stops, it will be off. Okay. I will leave this part a little bit later. We have here welding on off. I think adjusting, we have already talked about it. So adjusting, I can give you a little bit more info here also about adjusting. Adjust when you need to make any adjustments also in the program. So to change, I don't know, anything in the machine data, we will see this after. So you need to have adjusting on. So the machine knows that automatic cannot go on. So you can adjust something in the program or on the machine or. Welding on off. Okay, here this button, if you have it off, the machine will not weld. So you can also make, like you can here with this button simulate production, but without making welding. Sometimes you need to make sure that I don't know, maybe the speed is okay. Maybe you need to make sure after
One
making
second,
some.
sir. Yes, 1 second. We have a little feedback.
Yeah.
Okay, we're good again. We're getting interference, but no, there's no more interference. Please go ahead.
Okay.
Ali.
Yeah. Should I repeat a little bit adjusting or?
We were in that part that you can simulate without. You're in that welding part. Without simulating without welding. You're in the welding part after
you
adjusting.
okay. When welding is off, yes, the machine will run the complete automatic cycle, but without welding. So it's like you are simulating a cage production, but without a cage. So you can keep welding off and make all other things like, okay, automatic start, and then the machine will start turn and change the speed as it is set in the program, and the diameter will change as it is set also in the program. So it will you can also cross the light barrier and press on the foot pedal and remove the cage like you are moving a cage, removing a cage, but this is all without welding. So you don't need to put bars inside the machine. You don't need to put wires, and the longitudinal wire will not work. So the decoiler also is not turning. So this is the only difference. When welding is on, the machine should weld automatically during movement. This is clear.
Yes, sir. Clear.
Okay. You have here coil brake open. So I think it's clear. You open the brake for the decoiler. Main brake open. So you open the brake for the motor of the main wheel. Coil brake close is to close the brake again. So this is common. Okay, and this is the reset button to reset all the errors. Now I will highlight here a little bit, especially for the new operators. So to use these buttons, welding carriage and expanding cylinder, setback, expanding. So these are related to each others. What I mean is you need to move the welding carriage alone to the back. So you have a problem with a cage production, and then you need to move it back a little bit so you can, I don't know, cut a wire or make any mechanical movement. So to make this, first you need to have adjusting on. Then when you need to move the welding carriage, you have to press first on the welding carriage and keep your finger on welding carriage, and then you push expand. So the welding carriage will expand. You need to have both buttons pressed, but first is the welding carriage. So you choose welding carriage and then expand, then it will be expand. And if you need to put it back, you choose welding carriage plus setback. Then it will move in the other direction, or to the center direction. Expanding cylinder is the same. So when you need to open or to make the diameter bigger, you have to choose first expanding cylinder, always adjusting on, expanding cylinder plus, so you keep your finger on expanding cylinder and then you press set back, then the diameter will be smaller, or the expanding cylinder will move to a smaller diameter. If you press expanding plus expand, so you get a bigger diameter, or the expanding cylinder will move to have a bigger diameter. This is clear, or?
Yes, sir, clear.
Okay, perfect. So then we get to these two yellow buttons, so welding carriage synchronize and welding carriage reference. Okay, what does this mean? Synchronize, I'll start with synchronize. Synchronize mean that the welding carriage will be synchronized with the expanding cylinder, because the two parts should be moving together during production. So when you make a bigger diameter, the welding carriage should be also moving to stay on the same distance from the welding angle. So both should be moving together. I will put this picture just for you to know how. So when you make a bigger diameter, and you have to imagine that the welding carriage is in contact with the welding angle. So when during production you need to make a bell on the cage, so the welding carriage should move with the welding angle. You will make a bigger diameter, and the welding carriage should move also to make a bigger diameter. So when synchronize is off, then this cannot happen, and then you get an error on the machine that the welding carriage is not synchronized. Is this clear?
See?
Clear?
Yes, sir. Clear.
Yeah. Okay, welding carriage reference. Reference, what does reference mean? Reference means that the welding carriage will take the reference for the welding angle. We have, I will put again the 3D. So when you, for example, you make the reference for the welding carriage, and this is the maximum position, and you need to teach the welding carriage where is the welding angle positioned now. So you have to first make sure that the main wheel is on the, like on the zero, but it's not on the zero. I mean that one spoke should be horizontal. So the welding angle will be staying directly in front of the contact roller. When you press reference, then the welding carriage will move until the contact roller has a contact with the welding angle here. When it has a contact, then the welding carriage will stop and say, okay, I'm on the correct diameter now. Then you can, it's like teaching the welding carriage where is actually the welding angle, at which diameter. This button will be mainly used when you lose the reference, or you get the like a warning, please make a welding carriage reference. So you press on the welding carriage reference button. Is this clear? We will see this point again
Well,
after
it's
some
clear.
slides.
This is completely operations. Yes, this is completely related to operations.
Yeah, this
Yes,
is
but
operation.
when we're in the practice, so when the practice, it will be more clear for us anyway, when we're actually in the machine practicing.
Okay, but we will see this point again after when we are going through the control of the machine in the program. We will see this point as well. I think it will be now, it will be then clearer. I think
Okay.
we already passed 1 hour and a half in the presentation. Do you want 5 minutes break to drink coffee? I don't know, water, or it's okay for you?
Oh, yes, they want 5 minutes.
Yes, okay, so 5 minutes and then we come back.
Oh, but first of all, before you go, these 3 buttons here, what are they for?
Which
What
coil,
is,
coil break?
no, yeah, ese también, ese, yeah, and the black one on the bottom,
The blacks
underneath,
are just
no,
spare.
on the bottom, the one that has, yeah, that one.
Coil break close, to close the break on the coil. The coiler, you know, the unwinder has a break.
Okay, good, they understand.
Did you hear me?
Yes.
I don't know.
Yes,
Yeah, this is
Yes.
for the coil. Yeah, but maybe you don't have a coil brake, but many machines have. I'm not sure if you have a brake on your machine, but normally a brake you have. Sometimes you have
yes,
a
they do have a
pneumatic
coil
brake.
brake.
Yeah, okay. Then this is for the brake.
Okay,
Yeah,
so they're
sometimes you
going
need
to take
maybe to turn the coil or to make the wire smooth or something like that. You can open the brake, turn the coil, and then close it again. And this is just for manual use.
Okay.
Okay, so we
So
come
they're gonna
back
take
in
5 minutes.
5 minutes. Okay, great. Are we ready or?
Hi, Mr. Eli. Just give us a 3 minute more, please. There
Okay.
is coming. There is
Yeah.
coming.
Okay. No problem. So I think we are ready.
Yes, everybody just came in. I think we are ready.
Okay. So now we will move to the control of the machine. Oh, what's happening? Just 1 second. I don't know what happened. Okay. So for these buttons, we are done, right? Everybody is I think satisfied here. You have also on the control panel, also you can see these two buttons. These are one for the welding control and one for the speed. So I will just put my laser again. So this is for the welding control and this for the machine speed. Okay, with these two buttons, you can control the speed of the machine. From 0 to 10 is from 0 to 100%. This depends on the also speed which is set in the cage program. So if you put in the cage program maximum speed, I don't know, 15 turn per minute, then the 100% here will be 15. And then the 5% will be half, and then the 0 is 0. For the welding control, this is also to control the power of the welding. So you can say I need 60% or 70% or 80% or 100%. And here you can see these two light, so two LED. One is the welding pulse, one is the thyristor ignition. So because the welding, before making the welding spot, we have to prepare the thyristor to get ready to make this pulse and to give the order to the transformer to make the welding. So you can see here, you can control if the thyristor is working and if the welding pulse is done or not. So normally these two lights should come one after the other. So on, then this one on, then this one on, then this one on. So this should be like this. When sometimes you have some problems, maybe with welding, you can control also these two lights. Sometimes one light is coming, the second is coming, but not at the same rate. So you see that, I don't know, one time thyristor ignited, but there is no welding pulse. And so for 2 times, and then the third time come one welding pulse, then you can see, you can know that maybe something is wrong with the settings of the welding. You can play with some parameters in the cage program. I will show you after that which parameters are or can be affected by this thing. Okay, I think for this point,
I have a question here.
done.
One
Yes.
second, sir. Question. For the welding, is it necessary to always have it in 10? El plazo control.
Sí, en el control sí es necesario siempre tenerlo en 10.
In the control, it's always important to have it in 10, right?
Sorry,
the
sorry,
welding
I didn't get the question.
In the welding control, is it always necessary to have it in 10?
No. This you can, because sometimes you say in the cage program, you say I want the transformer switch is on 2 and or 3, and then you put 4 welding period. But this we will speak on about it after few slides, I think. And then you see that this is too much, and you need maybe to reduce it. So during production, you can play with the power. So you can reduce it to 70%. You say it's too less. No, I need maybe 80% from it. So you can adjust this a little bit during production. Is this
So at the end of the day, the operator adjusts. So at the end of the day, the operator adjusts is the one that's in charge of adjusting this.
yes? When he see that, okay, maybe for some cases you have I don't know, a problem when you make a bell, and maybe you need more power. So maybe the operator during production, when the machine start to make the bell, he can increase a little bit the welding power, or or reduce it. This depends. So these are made for this reason. Yeah, but normally we put 70% or 80% from what we put in the cage program. Sometimes you need 100%. It depends about the whole situation. So the wires you are using, the material, the machine status, the welding angle, the contact roller. So many things comes here to make this control. But normally 70-80%, this is what we use here, but when we test the machine.
Good.
Is it okay? Yeah, okay. But okay, we will see that this is here the fine control. The main values you enter in the cage program. But here you can still play with the adjustments a little bit during production. So you see that you need a little bit more power. You can give it from here from 70 to 80% then. You see that you need less, you can control this. You see also that at some points when you move a little slower with the machine, then you get better result for the cage is more round. I don't know. You can also play with this. So the operator here can decide if he needs to do it or no. But for the speed, you can put it on 100% and run one full cage. This is no need that with every cage you make this control. But in case needed, you can also from here during cage production change the speed a little bit, and maybe also the welding power. Okay.
Okay.
Yeah. Okay, this is the machine layout. Here, for the safety, we have two, if you want, two areas. So this is the thread up area, and this is the cage production and cage removal area. So each side is protected with light barrier. So here you have light barrier between the control panel and this point, and here you have light barrier between this and control panel. So we use the safety barriers are also used to control, or are included also in the control of the machine, which means that when you go inside the thread up area and the cage removal area is okay, so no one is inside, or so I mean that the light barrier is not interrupted. So we allow in the program the rotation of the main wheel, but with a limited speed, which is 10% or 10 rounds per minute. So very low speed to make the thread up of the machine. So the operator enter here, and then when he press on the foot pedal SF here, thread up, then the main wheel will start turning and he can feed the machine with the wires. When he finish, he press on start, then the machine will make one welding point. He go out, and then he can press reset and automatic start, then the machine will start production. If the operator is here or in this area and making thread up, and someone pass from here, then the machine will stop emergency. And he cannot make again the thread up until he go out, and the second, he needs to make sure that the second one is also out. Then he can make a reset, then thread up, cross again, and put pedal SF fear SF4. Then he can again start production or start the thread up again. If for any reason someone during production cross this light barrier or that light barrier, the machine will stop immediately as emergency stop. And when the cage production is done or finished, to take out the cage, the operator is allowed to enter from this side. So the light barrier will be crossed. And when the operator press on the foot pedal SF9, which is cage removal, then the feed drive will, or the clamps will open, and then the feed drive will move back to allow the operator to take out the cage. Is this clear?
Here.
Yes, sir. Clear.
Okay. I think here we can also simulate this tomorrow if you want, directly on the machine after we finish the online session. Now we will go
But
to the
question,
main.
question, sir.
Yes. Okay. I like questions.
In the control panel, there's a key in the control panel.
Mhm.
What is the purpose? What is the function or the role of that key in the panel,
Yeah.
in the control panel?
This is this when you need to make the maintenance team comes to make any maintenance, and they don't want anyone to move the machine. Maybe they are sitting behind the machine and no one see them, so they can turn on the key or switch to the maintenance mode, and then take the key with them, put it in their pocket, so they are safe inside the machine. When when the operation mode is changed, then no one can move any, so all the drive will be like in emergency stop, they will not move, so no one can do any movement in the machine until you switch back to the normal mode. So this is for safety reason. So it's we always recommend to do that. So when anyone is or wants to do any mechanical or any intervention on the machine, and he is not sure that someone will come and play with something on the machine, then he has to switch the key and take it with him, put it in his pocket. When he finish, he can put it again in the machine and run it to the normal mode. This is the purpose for this key. Clear?
Okay.
Okay. So now we are going to move to the control of the machine, to the main machine screen. I'm sure that every or most of you have seen the machine screen, main screen of the when you turn it on, then it will appear to you the screen. Before being able to do anything, you have to log in to the machine. So when someone press on log in, then show, he has to enter the password, and then he will be able to start making some changes on the machine. Otherwise, he will not be able to do anything. Here I wanted to have the machine online, but okay, I can have here a simulator. This is like a simulator. Now no one is logging in. If I go here and put show, then I have to enter a password. If I enter any password, okay, this will not be okay. Then if I try to make anything, it will always ask me, please log in. If I try to do anything on the machine, like changing something in the machine data, I will not be able to change anything until I put the password. I will put my password now. Because I pressed before on machine data, so it opens. Yeah, now here you will see who is logged in. If you go here to extra administration, then you can see the password levels. So, okay, I put the highest level I can manage the machine, which is level 9. Normally, operator has number 2 or 4, level 2 or level 4, and level 6 is for the maintenance. That's where you can also, with this level, you can set the reference, you can make some adjustments on the machine, not everything. And with our password, you can do almost everything. This we don't give it to anyone. This is our own password, but number 6 is we give to the maintenance and to the customers. If you want, I can log in with a low-level user so you can see what you will see. So now if I go, now I'm with user level 4. And 6, I will prefer to make it with 6. Now 6. Okay, when you have user level 6, then you can create user level 2 or 4 or 6, but you cannot create new users with more levels. So to create a user, you can make a change, you can insert user, or you can log out, you can delete a user, and yeah. So if you want to create a new user, so you can just press here, insert. So you get create new account. So I will call it Eli. No, so sorry. Permission. So which level should I create? I need to create an operator level, which is permission number 4. Then it will say what is your username. I will say my name. And then you create here a password. I will put 1, 2, 3, 4. And then, okay, then I have this user created with the password I just make it. Okay. Is this clear? I think this is needed one time, and then when the user is created, so it is it's done. Okay. And
Okay.
yeah.
Okay.
So before starting anything, we have to log in. Then we can start our work on the machine. So during normal operation, during automatic operation of the machine, here you have step display. This part, it will be shown. So when the machine is working, you will see here the steps which are going to be executed during automatic mode. So sometimes you stop, I don't know, you have a problem on the machine, and then the machine is here. You can see here which step is going to be done, or and where it stops. Then you can give us this information. Maybe sometimes it helps us to manage the situation and to say, oh, okay, it could be this or that, or this. This we can test tomorrow also if we make online, if the machine was online and we do something together. Then to create some program, we have here production menu. Okay, program here is just to close the program, but so it's not important. This is why I just didn't put it. So when you press on program, you have exit only. You don't have anything else. So we will continue with production. When you press on production, then you have the list, production selection, cage program, multi-program, production list, and production archive. If you press on production selection, then you get this window. If here you have to choose if you need to produce single program or multi-program. Okay, production list, forget about it because it was made one time and we are not using it anymore, but it's still here for any reason, I don't know. So mainly we are working with single program or multi-program. Cage program. Then to create a program, you need to press on cage program, then it opens this windows. Okay, here I used also your backup of the machine, so I think you still have these programs. I don't know, but this was done one time with you. When you select cage program, this windows will open. Here you have the production setup where you can choose winding wire guide, brake reel. If you have this option, sometimes you need to make a brake. This option is normally used when you make oval cage, but in your case, this is not used. When you make oval cage, normally at some points you need less speed for the winding wire, so you make a brake, but in your case, you don't need to think about it. You can choose the option to make automatic start after resetting light barrier, which means that when you come back from the thread up area, so you went inside, you make the thread up, you press on the foot pedal start, and then you go out. Normally you need to reset and press automatic start. If you choose this option here, automatic start after reset, so the machine will restart directly after you reset the light barrier. So you press or reset and the machine will start automatically immediately. Normally this can be used, but I prefer that always you double check that the winding wire is well connected to the longitudinal wire, and then you press on automatic start. So you can just take a look and then press on automatic start. Winding wire brake always on. Okay, this is you put the brake on so you don't. This is for the, this is the winding wire guide brake, and this is the winding wire brake. Okay, when you put it on, then the machine, in your case, you don't have a motor on the decoiler. So you need to have the brake on to be able to push the wire by the machine. When you have a motor, then the motor will open automatically the brake. Here, are the reels that you are using. So sometimes in your case, I think you have one reel, one decoiler, but it can be some customers have 3 reels. So you have to choose here which reel you are using for the production. Okay, and then here you have welding point lengths for each record. This we will talk about it in next slides because it is related with the records data here. Here in the cage program, you can also enter the production data. So the production data is you have to enter diameter of the longitudinal. This is in this case 6 millimeter. But these two, so the diameter of the winding wire and for the longitudinal wire are only information. So the machine, if you put 10 or if you put 6, this changes nothing. But this is only for the information, for the operator information, and for anybody wants to look, okay, which wires are we using now, and for the also record list. So because the machine records every time we make production, we record these data, so you know that how many wires did you or which wires you are using and these things. But for control and these things, this has nothing to do with the machine. Main wheel thread up speed. So when you this here, you can change the speed of the main wheel when you make a thread up. When you press on the foot pedal, the main wheel will turn, but here you cannot put more than 10% for safety reason. So some operators are, or some wires maybe are heavy, some wires are less heavy, then you can control the speed here for the main wheel. It turns faster or slower. Diameter for the start difference diameter. Okay, this option, sometimes you have at the beginning of the cage, you have sometimes a little bit bended wires to the inside or because of the pressure. So you can use this. So the expanding cylinder will move a little bit. So here in this case, let's say if it is 5 millimeter, it will move 5 millimeter to the inside more. And then when the clamps close, the expanding cylinder will open again. So this is like to recover the bend which made at the beginning of the cage. I don't know if you faced this problem before or no, but sometimes this is the case. Is everything okay now, or I can continue?
We have a question. 1 second, sir.
Yeah.
Question. That parameter, the last parameter you just mentioned, can that be changed? That parameter? Can we change
Yes, you
that
can. You
configuration?
You can. This you can. This you can also put
Like
it
if I
zero.
don't, like if I, la puedes colocar en cero. Like if I want to make it 5 millimeters.
Sorry, I
Can-
didn't
can I
get
do
the
that?
question.
Si lo quiero hacer, ¿qué fue la pregunta? Like if I want to change it from 5 to 3, that's possible?
Yes.
And what is the
This
maximum? What is the maximum?
I think it's 10 millimeter or yeah, it's 10 millimeter, I think. But we can try it. It's sometimes you don't need it, but it is just when you need it.
Okay.
Okay. So welding catch start position, it is 0 millimeter. Okay, this is normal. Speed drive start position 35. This is the minimum we can put. You can sometimes you need maybe a little bit distance at the beginning. You don't need the winding wire on it, so you can put here maybe 50 millimeter. So at the beginning of the cage, the feed drive will not stop very close to the welding angle, so but a little bit back, and then it will start from there. I will put the 3D. I think it's
Question.
Yeah.
Can you repeat the last parameter, please?
feed drive start position. I will repeat it, but I will put the 3D on, so everybody will be. Just 1 second, because my laptop. Okay. So normally, when you need to start, when the start position for the machine is that the feed drive is here. So this is the minimum position. And we set the minimum at 35 millimeter. This is the minimum that the feed drive can reach on the rail. If for any reason you want to change or at the beginning of the cage you want more longitudinal wires without being welded with the winding wire. So this parameter which we have here, this 35 is the absolute minimum. You cannot put 25, but you can put 50. And when you put 50, so the feed drive will not stop at the 35, it will stop at 50. So a little bit back. And then the machine will start production.
Okay, clear.
Clear?
Yes, sir.
Okay. Main drive cut position. Okay, this is when you have a automatic cutter. This parameter is important, so you can say that the main wheel should turn 20 degrees and then the automatic cutter should come and cut. But in your case, you don't have, I think, automatic cutter. Welding carriage cut position. So also this is the position when the cage is done from production, the welding carriage will move 10 centimeter back and then the cutter will start cutting the wire. But this is not applicable in your case. Feed drive cage removal position. Okay, this is where the cage, when you press on the foot pedal, SF9, which is the cage removal. So the cage, the feed drive will move to this position. This is the maximum position, will move to this position, and then you can take out the cage. This you can change. Maybe when you make a short cage, you don't need that the feed drive move to the back. So it moves only maybe 20 centimeter, and this is enough. Then you can take out the cage and restart again. So you don't lose time. Is this clear?
Yes, sir. It's clear.
Yeah, okay. So just I will repeat the last point. So if you make short cage, so like this cage, so instead of moving the feed drive to this position, it moves a little bit back, and then when you remove the cage, it will come again to the start position. So you don't lose this time to move the complete way back, and then this you can regulate for each program. This is the importance of this parameter. Rewinding wire brake pulse. Okay, this is when you make brake, but in your case you don't need this. How much seconds you make the brake. Okay, we move to the welding data. This is important now. You have the welding power. Okay, here is 0, but normally it should not be 0. Because I took this from
It should be 80.
this.
It should be 80, right?
Um,
It should be 80, 80, 80.
No, it could be 100, it could be 70, it could be. This is depending on the gauge, on the wire diameter you are using. When you use 10 millimeter diameter, maybe it could be more. But 80 is, yes, is a
Question. Hello, Senta.
yes.
Another question, sir.
Then
How do we determine the welding power depending on the diameter of the wire?
yes, I can show you a table what we suggest, but we can never say, okay, this welding power with this period is perfect for this wire, because for each supplier this differs. So depending on the material, depending.
Can you please share with me that table via WhatsApp? That would be wonderful if you can share the table via
I
WhatsApp.
think this is in the machine manual. I will try. I have to see it. It's not in front of me now, but I can. Yes, of course. But I will check in the manual. I think it is already there in your machine manual.
Okay. And in what? And depending on the diameter, in what position do I place the transformer? Depending on the diameter, in what position do I place the transformer?
Yeah, this is okay. We say for big diameter like 10 over 8, let's say, or 8/10, we say 3 or maximum 4. So 3 should be okay. But this is all included, I think, in this table. I'll just try to, maybe I can get something quickly.
Okay, perfect. Yes, sir.
I will share. This is from. Uh, this is recommended, but you can start from here. But sometimes you need to make optimization. You see this table? Yes, here you have the diameter of the longitudinal, the winding wire diameter, then which level of transformer. So what is the recommended time for welding, the welding power, the pressure for the welding roller, and the pressure for the contact roller. So this is our recommendation, but as I said, it always differ from supplier to another, from customer to another, from the situation of the machine, of the parts. So sometimes it's not 100%, but at least when you do something new, you can start from here. So if you have 6/7, then you can start with the welding transformer 3, with the time is 3 and power is 80. So this is like a base where you can start your trials. If you see that you need more power, you can put more. You need more pressure, you can put more. So as you see here also, that the welding is not only one parameter and done. There are many parameters which affect the welding. So but okay, I can send you this table per WhatsApp, not the problem. Is it okay? I can.
Okay, perfect.
Yeah.
Yes, sir. It's okay.
Okay. So okay, I will put this. This is the simulator. Okay, for example, for this gauge, we are using 85 like welding power. The welding transformer switch is on 3, but okay, here maybe we have 6/5. This is, I think, too much. Okay, the welding switch on 3.
What is the maximum? What is the maximum for that parameter? The maximum.
For here? You mean here? For the welding transformer switch?
Yes, for that one.
This I think this is 4. I think this is 4. This is a switch on the transformer itself, so you can turn it to the maximum. I'm not sure if 4 or 5, but
4 o 5. Okay,
okay.
I think it's 4.
Yeah, I think so. Also, I think also is 4. I'm not sure for bigger machine. Maybe we have 5, but for your machine is 4. Welding point start. This is something I have to explain a little bit in details. Okay, this is where we start. Let's say um, the welding control. What I mean, just give me 1 second. Yeah. Okay. This parameter is depending also on the diameter of the cage. So when you have smaller diameter, you need to start the welding a little bit niche, not earlier, but a little bit late. So you change this parameter to a smaller number. And when you have bigger diameter, you have to start this a little bit earlier. I have a table. I wanted to share it with you. I hope I will find it now. It's also regarding this point, so which clarify how this parameter is affected by the diameter also. Okay, I didn't find this table, but I will look for it for tomorrow.
Yes,
okay.
I think because that's very important for us.
Yeah, but just to understand the logic. So when you put here -6, so that means that the welding will start, or the welding pulse will start 6 degrees before reaching physically the welding angle. So in this case, you have the time to prepare the thyristor, and then when it is time, you give the order to make the welding pulse. So these two lights, you remember these two lights that I spoke on before on the machine? These?
Yes, they remember.
Okay. This is related to this. So when you see that these two lights are not simultaneously on and off, then it could be that this parameter is not okay or not good setup. So you need to change it maybe to make the welding a little bit earlier or a little bit later. So it depends about the diameter and how many spokes you have on the main wheel. So when you have 36 spoke is different than when you have 12. So maybe sometimes you have more time to prepare the thyristor. Sometimes you don't have this time. You need to make this adjustment here.
Question, sir. Question.
Yeah. Okay.
In the welding angle, what is degree zero? What is degree zero in the welding angle? In order to be able to establish the degrees before and after to prepare the welding, what is degree zero?
This is the same when you put the spoke on 0 degree. This is the same. So when you put the main wheel on the 0 degree, you remember how mechanically we did it. So this is a 0 for everything related to this spoke.
Can we please see this in the 3D, in the 3D version, please?
Yes. So this is the 0 degree. This is the spoke horizontally. This is the welding angle here. This is the 0 degree. So it's all together.
Perfect.
Okay. So every time you make a turn, so this one will be
Another
here
question.
and it will be aligned with this one, and the 0 degree for this one will be here also. So every time you turn, so this is how it works.
Another question, sir.
Yes.
What is the maximum parameter to establish in the welding angle?
Sorry, I didn't get this. What do you mean with the welding point start? What is the maximum?
Yes, exactly. The welding point start.
I will just, yeah, I will explain to you maybe in a good way. So when you have, this is depending on the main wheel. Okay, you have here on this wheel, you have 1, 2, 3, 4, 5, 6, 7, 8, blah, blah, blah. You have, I think here, 24 or, okay, let's say we have 36 spoke. Okay, so this will be 360 divided by 36. So it is 10. Because if you put more than 10, then you will be interfering with the welding angle before. This is the maximum you can put, plus 10 or minus 10. When you have a machine with 24, let's say, so you have 360 divided by 24, you have 15 degree. When you have only 12 spokes, then it will be 30. So it depends. This is not something standard for all machines, but this is depending on how many spokes you have. So the degree between these two will differ from one to another. Is this point clear?
Yes, it's clear.
Okay, so this is how you have and how you can make it now by yourself. You can see, okay, my machine has 36 spoke, so I can 360 divided by 36, it's 10 degree. This is the maximum I can put, and then you have to manage for each cage, depending on the diameter, how much I can start earlier or later. And then after this, to make a more fine regulation, you have the welding point shifting. This one, you have it on the, this is a gray, and you cannot change it from here, from the cage program. But this, you can change it from here. Okay, I will go back. And this, you know, these two, welding point later, welding point earlier. Okay, this is related with this one. So when you say here -8 or -6, and then here you see -2, this is from where it comes. This comes from here, from what you have here selected, because during production, you have to monitor the sparks coming out from the welding. If the sparks are in the middle, then you are okay. If you see that the sparks are going more to the upper side, then okay, you say no. I'm starting maybe a little bit earlier the welding, so you have to make it later. So you can press on here, on this one here, and then you can regulate it directly. And this parameter will be saved when you change it from these two buttons here. It will be saved here. So once, so it will, yeah, like if you have now 6.2 degrees, -6.2 degrees. Did you get this? Hello?
I didn't understand the last part with the buttons. Could you please explain the last part about the buttons?
Yes. I will try to put these two here. Maybe this is clearer like this. Okay. I cannot use the laser, but I think you can see my cursor, right?
But we only see one screen. Oh, there's, we see both. Yes.
Okay, just a second. Okay. So you first you made this cage new. So you make this is the first time you make this cage. You make new program, and then you put the name and blah blah blah. You made this program new, and then you don't know. You say okay, approximately I need -6 here, and then you start the production. Then you see that okay, -6 is approximately okay, but you need the sparks. When you monitor the sparks which are coming out from the welding, you see them. If you watch my hand now, it will spread like this. So sometimes it's spread like this, so to down, or sometimes to up. When it is in the middle like this, then it is perfect. When you see that it is like this, so the sparks are going more up from the welding angle. So the welding angle is here and the sparks are coming out like this. Then you see, okay, maybe I'm doing the welding too much early. So the sparks are going up so early. You have to make a little bit later the welding point. So you use this here, welding point later. You press on it, you can press on it, and then the value here will change from 0.2, -0.2, -0.4, -0, blah, 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 until you can see that the sparks are in the middle. Then you are okay now. This, what you change here, it will be saved in this case here. So you can see it after later. When you produce the same cage, you have the same settings. So it will, you adjust it one time and it is saved here, and then you can make your production every time you make this cage, the same settings will be applied. And this value here what you see here will be added to what this value that you put here in the control, in the background of the machine. So in the PLC and the welding control, it will be added. So you can produce without problems the next gauges. Is it clear now?
So.
So okay.
So.
Yeah. This is something not easy, I know, and it's not also easy to explain from distance. So, but next time you go to the machine and you see the welding sparks, and then you play with these two. So make it a little bit earlier, make it a little bit later. Then you can see that the sparks will be not coming as usual. So you can produce, and then you start playing with these two parameters, and then you will see that the sparks are shifting up or shifting down. But the best would be when it is in the middle. So the same amount will go up and down, up and down. So this is how I can explain it. I don't know. Maybe I can have a photo or something, but
now it is much more clear. Thank you so much.
okay. Okay. Now maybe I try to prepare something for tomorrow. I hope I will have enough time in the morning. I just put a note. Okay, so then we go. I will move to the next point. Is it okay? We can speak about the welding point shifting tomorrow. Maybe I prepare some pictures, and maybe I try to get a video. Is it okay?
Okay.
Okay. Welding length is the number of periods for the welding. You know, in the electricity, you have each period when you have 50 hertz, each period is 20 milliseconds. So this is how many a period you need to make the welding. So this is directly related to the power. So when you put 4, so it is more, you are making the thyristor passes more power to or to the transformer, and then to make the welding. So when you put 4, it is 4 periods. This is the during normal production.
Question.
Yeah.
What is the maximum parameter? And second, what is the adequate parameter? What is the maximum and what is the adequate parameters?
Okay, okay. As I told you before, adequate, I will send you this table. This is what we recommend as a start. But always with welding, it's not, there is nothing standard. So some customers are using I don't know, 4 period to weld 8 on 8, and it's working, and some are using 6 periods to make the welding 8 to 8. So it depends about many factors. So this is nothing that I can say this and this should work and this is done. This is not the case. Unfortunately, it's not the same, because every supplier, when a customer changes a supplier, sometimes he has to adjust all the weldings, all the welding settings on the machine to be adapted to the new material he is getting from the new supplier. When you put everything new to the machine, like copper and you change the welding roller, and everything is new, maybe you need less power to make the same welding, because now everything is better, and the resistance to the current is less. So there is nothing like standard. I hope you can understand this point. This is all related to the material.
But what
the
is the
material.
maximum?
The
But what is the
maximum.
maximum
I think here it's 100. If I'm not sure, I have to check in the program how much is we are limited. Okay, I have to recheck this what is the maximum, but normally with 8 or 9 you can weld almost everything. This is what I can say now. Is this okay? Okay, I will check. Okay, then we have the welding point length beginning end. So this is sometimes you at the beginning and at the end of the cage. So the first welding and the last welding, you put more power on it just to make sure that it holds, because the first welding point is usually taking a little bit more power to make the winding wire start to move. Sometimes we put more power on the first and the last one to hold the wires together more. But it can be 4, it could be 5, it can be 6. This depends on the customer and on the experience. Okay, but this affects only the first and last welding point. We have also the welding position beginning end. So this is normally 0. Then you have one welding point at the beginning and one welding point at the end. If you put here a value like, I don't know, 2 degrees, so what will happen? The machine will make the first welding point, will make 2 welding points at the beginning and 2 welding points at the end. The main wheel will move -2 degree and make the first welding. Then it will move +2 degree and make the second welding at the beginning. Then it will continue production, and at the end, before the last welding point will be done the same way: -2 degree one welding point, +2 degree one welding point. So when you put a value here, then you get 2 welding points at the beginning and at the end. Is this clear?
Can you please extend the meeting for 5 more minutes, because it's going to close right now. And
Sorry,
the meeting is going to close. The meeting is going to
yeah.
close. Could you please click on extend? Like the meeting in Teams, or because I think it's 2:58, like the clock on the top.
Are you sure it will close alone?
¿Están seguros que va a cerrar solo? Yeah, it says it's going to close.
Okay.
But if you can actually extend. But I have a question. I have a question related to the last point.
Yes.
This parameter here, this is the number of times that it welds at the beginning and the number of times it welds at the end, right?
Sorry, I didn't get your question.
This parameter is equal to the number of points that it welds in the beginning and the number of
No. You can put here 3, but it will still make 2. This is only the degree that the main wheel will turn. So if you put 3, it will turn -3, make a welding, +3 and make a second welding. So it will be always 2 weldings. If you put 5, you can put 5 here, and then it will move -5, +5, but it will make 2 weldings. But the first welding will be when the main wheel is turned to -5, +5, and then the production will start.
Okay, okay. And the last point, the one on the bottom, welding angle position. Can you please explain that last point, welding angle position?
Yes, I will. This is the next point. So this is the position, the mechanical position of the welding angle. As you know, here, okay, I will go back to this picture. So this is the position. Mechanically, where did you put the welding angle? Where did you assemble mechanically? So this here should be equal to which position you have done here. So it's position 1 or position 2 or position 3. This is very important. If you put it wrong, then the diameter will be wrong calculated.
Okay.
Okay. So these are okay. Contact block length, contact block offset, welding. These are fixed values for the mechanical parts which are on the machine. So contact block length, it's so when you order the machine, you have, let's say, contact block. I will show you this on the 3D. It will be easier. So okay, so here, so this is the distance of this one from here to here. So how much do you have? Some welding angles has longer copper here. So this is the parameters what we enter in the here. So contact block length, and the offset is also fixed when we manufacture the machine. The welding roller pressure, 3 bar. This is the pressure we put on.
Question.
Yes.
Sí.
Yes, tell me.
Sí, por favor, cuéntame. ¿Qué pregunta? The two previous parameters.
Yes.
Before the pressure parameter.
Yeah.
They're only informational. They're only for
These
information
are
purposes?
no. This will be entered in the calculation of when you put here, let's say -6, and this is also will be influencing the speed of the machine. So when you have longer contact block, then you can weld for longer time, but maybe the machine will be slower. So it will enter in the calculation of the machine. So here. And also when you read here the maximum speed, this will be affected directly also by this data. Can be affected. So.
Okay.
Is it clear?
Yes, sir. Clear.
Okay.
I would believe that this. I think we can finish this last slide, and then we'll start and then we'll continue with like let's wrap it up for today with this last slide, and we'll continue tomorrow.
Okay, we can, because we start a little bit late. We can continue a little bit more if you want. For me, it's not a problem. We can finish at least this okay, welding data, or maybe it will need more, maybe 30 minutes, I'm not sure. But if you want, okay, I can also stop. It's not, for me, it's not a problem. So your decision.
Okay, so let's go in 17 more minutes. Can we go 17 more minutes? 17?
Yes. So until
Like
we
almost
reach
20 minutes.
five.
Yeah.
Okay.
Yes.
Yeah,
yes.
we can do that. We can do that. Okay, so the welding roller pressure. This is the pressure in bar for the pneumatic cylinder that we use here on the contact roller. Okay, I'm not sure is for your machine this is automatically adjusted, or you have manually a manometer where you can regulate the pressure for the contact roller. But when you have automatic pressure regulator, then when you
It's a manual. Ours is manual here.
yeah,
It's
yours is
manual.
manual, but when you have the option of automatic, then you can here change it, and then it will automatically change on the welding on the contact roller. Okay, but it is important to put it here also when you use a manual manometer. So for the operator to know, so because sometimes you change program and then instead of using 3 bar you need to use 2.5 bar. So it is important for the operator to read this and then to regulate the manometer to 2.5. This is just done, then it will be only an information. Okay, welding roller type, it is one. This you don't have to change, and you should not change it. This is also depending on the welding roller you are using. So this will be determined when we manufacture the machine. Actually, it's approximately for 99% of our machine is one. Okay, because sometimes for many some special machines we use a thicker welding, sorry, contact roller, then this is another type. But in your case, you don't need to make any change. This you don't change it in the machine lifetime. Okay. And
Okay,
now
we're
we
good.
go to the welding angles. So we are always in the cage program. So this is all is for the cage program. So you need now to make a cage. Okay, you see here you have for your machine you have 24 spokes. So the maximum degree you can put is 15. Here the maximum is 15. But okay, maybe you don't get to that much, but this is the maximum that you can put theoretically. Okay, here you can choose the welding angles or the welding points on the cage. You have here the 2, 3, 4. So when you put all, then everything will be selected. If you put 2, so it will be every second welding angle will be there will be a welding point. If you put 3, so every third. If you put 4, every fourth. Or you can just select what you need. If you may make a special cage, you see here. So here you can see which point you are welding. If you put all delete, you make all out. Okay, and most common that the customers use one yes, one no, or all. Very less use a special cage. Okay, when you choose this, like one yes, one no, so here you can go up to 30 because now you have 30 degrees between two welding angles, not only 15. Is this clear what I'm trying to explain about this parameter?
Yes, it's clear, sir.
Maybe with a little bit more, when we go a little bit more with the explanation, it will be clearer and clearer. Okay. So this is here you can see also which are the position where the welding point will start. So here is 30 minus 6 degree, because here is minus 6. So the start will be when the main wheel will be at 24, not at 30. It will start the welding when it is on 54. This depends from the parameter you are using here. Okay.
Okay.
Okay, now we go to the record data. Here, this is very important to make the cage. Okay, you chose here how many welding angles you are using. So here we said, okay, we will use one yes, one no. And then here you set the shape for the cage. So when I choose this one, so you see here it becomes red. So this is this part. We have the zero winding is this is when you start the cage, the machine will make 14 zero winding, which means that 14 times or 14 weldings will be done without moving the feed wheel. So this is the main wheel, this is the feed wheel. So the main wheel will turn, okay, and then without moving this, it will make 14 welding points, and then it starts to move. So you get at the beginning of the cage, all the wires, or 14 wires, will be with welding spots. Okay, and then the diameter is the diameter of the cage. So the first record length is this part, how many millimeter. The spacing is the space between two wires when you make the wires. So this is the spacing we call. I will maybe, oh, every time I prepare something and then move to something else. Okay, if we put here 100, you see that 100, the one wire will be less maybe. Put 72. The record length is the length from here to here. This is 80. If we put here 1000, then it will be this part. So in this part, we will do a spacing of 72 millimeter of winding wire. If we increase this to 100, the spacing between these two wires will be more. If you put it 50, it will be less. You see? This is here where you manufacture the different parts of the cage. Then you move to the second one. This is you need the same diameter but with record length 90, and so it will be 90 with also 72. Here, okay, the first one is the speed of the cage. So you will start with 8 round per minute, and then we will continue with 14. And then here also you will continue with 14, then you will make this part with 11, and then this part with 11, and the last part with 8. This is the speed of the main wheel. You can make sometimes in the middle zero winding, but usually the customers don't do it, but if you need. The diameter is still the same. Here you need to make this part with 72 spacing also. Okay, I come here to welding carriage offset. I don't know why here you have -2, but normally, usually we use this parameter when we make the bell, because the expanding cylinder will be expanding to open the diameter, and the welding carriage we should also be moving at the same time. So sometimes and the winding wire is turning at the same time, so the main wheel is turning. So to get sometimes we lose a little bit of the pressure on the wires when we make the welding. So to avoid this, we can here put welding carriage offset. So instead to move that the welding carriage move to the 1277 diameter, it moves to 1277 -4. So it's like keeping a little bit more pressure on the welding roller. So you get better welding on when you do this bell. This is mainly where this option is used. Okay. Then at the end you make zero winding. Zero winding is the same as at the beginning. So the feed drive will stop and the wheel will turn until you make 15 welding spots at the end of the cage. When you have wire brake, you can here also tell the machine to make a brake, but in your case, you don't need this option. Here you can also choose where to make the brake. And for the welding, I want here to come back to this point. When you say here welding point lengths for each record. So in this here, you can change when here is 1, then the machine will take the data from here. So here we are welding with 4 periods. Then when this is here 1, so okay, for everything will be with 4, like like this parameter. If you need for any reason at some points to make stronger welding or lighter welding, you can here just enter how many periods you need. You can change it here to 5. So when you put here 5, so at this length, the machine will make 5 weldings during production, not 4. If you need to go back to what you have done here or what have you have entered here, then you can just put back 1 and then done. Okay. At this page,
Okay.
you see at this page you can see the calculation. Okay. Before moving to this page, here when you enter the data, you see here the maximum speed, and this is the total length of the cage. Okay, this is the wire consumption, so approximately you need 32 meters per minute. But what is important is to know the maximum speed and the total length, because sometimes you enter here values and you need to make sure that the length is okay. You get the drawing of the cage and you have 2450. Okay, I have here the total length wrong, so maybe I have to reduce 10 millimeter. So now I have, okay, total length is 200 to 2450. And also the maximum speed that I can use for this cage is 19. If I put here 20, then the machine, when I load the program, it will say there is an error with the speed. I cannot put more than what is here. So it was here 14 before. Okay. So you can see here something. If I change the diameter, so now I use 1277. At this diameter, I can use 19 speed. If I go lower with the diameter, then I can use a little bit more speed. So it's related to the diameter as well. So if I make a bigger cage, the round per minute will be less. Who already produced with the machine, I think, knows that. Let's see, this is 200, so this is
Yes,
a bigger diameter cage, and you can see here that the speed is less. Okay. One other thing, if I change something here, let's say I put 18, and then I want to check something on this program. I go here, and then I go back, then this is not saved. Then everything I made, gone. So every time you need to make sure, okay, this is what I changed now. I need here to run with 19 speed. I have to save the program. So I have to make edit, store program, then it is saved. And when I move to other program and I come back, then it is still 19. If I change it to 2, I don't know, and then I go to another program and then I come back, then it will not change. It will stay the same. So any parameter you change, it will not be changed until you save the program. If you don't save, you lose everything you did. All the changes you did will be lost. You need to enter that again. You saw we made here H2, but then I changed. And then when I come back, it will return. I have first to save the program, store, and then when I go back or when I change, I close, I do whatever I want. Then I go to the production KG program, and then I can see that this is changed. Okay, it's not changed because, okay, now I changed here. Yes. So now it's changed. If I put all and I don't save, nothing will happen. If I save, I will save again. I close. If I go up again to this, it is saved. If I choose 4 and close for any reason, I forget to save, I go back, it is not changed. These are some important things that you need to know. Okay, now I explained how maybe to the parameters and all these things, but if you are new and you need to make a new program, or you don't have any idea about these things, so I will start from the beginning. Production page program. I can here create new program. I can copy a program and then delete program, rename program, save. Okay, if I need to copy this program, I stay on it and then I make copy program. When I press copy program, then insert program will be light. Then I can choose it. Before it was blind. I cannot click on it. But now I can. Now I put insert, then it will give me the same name here. I have to change it. I don't know, test 1, and then okay. So now I have the same, but test 1. Maybe this gauge is approximately the same, but I will need to use, I don't know, 8 millimeter instead of 6. This I don't have to change maybe. And then here, okay, I use 8 millimeter, maybe 80 is still okay. And maybe I need here to put the transformer to 3. This is just an example. And the welding start point, I need it 7 because it's a smaller diameter. The welding length, because it's bigger, I need to put it 5. And okay, the first welding point for me, it was okay. I need to use welding angle 1, 2, 3. I don't know. This is how I can change. I need to use all, and then here I need I don't know, 5 welding, 0 winding. The diameter I needed is 1,300, and for I don't know 100 millimeter, and the spacing is 50. So I change what I need. Here I can make a row copy, and then I make insert row, so it will be inserted. Okay, I made for this one. Okay, I can make insert row, so it is inserted now. I can change if I need to add some things. So this is just for your information. You see here the data, how it changes. We can do 1,300 for everything. Okay, I can put here raw value for complete column, so it should uh, yes. Now all the column is 1,300. I need it at the end with a little with a small bell. I make 1,400. I don't know, and here also 400 and 1,400. Then I made this. I don't know. For here I need 2,000, and then this is the cage I want to do. So this is just an example. Before 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 going out, I don't have to forget store program. Now it is stored. Otherwise, the changes I made will be gone. Okay. When I need to start production with this cage, I have to choose it and then program, load program to PLC. Okay, here I cannot because I don't have a PLC, but usually when you load it, then it will go to the PLC, and then you can see the program here, the name of the program here, and you can start production. I think we are done for today. Any questions on the last part I mentioned?
No, sir. But he has one doubt.
Yes.
What is the multi-program?
Yes. Okay. This will be okay. Now I showed you the program. Multi-program will be tomorrow. Our start, because first you have to make programs. So now you know how to make a program. Then multi-program. This will be our next step. In multi-program you use, so just to give you a small idea, so you use the programs you already created, and then you can combine them in one program. So let's say you have to make a series of production from, I don't know, one cage with one inner cage for 1,000 diameter, and the outer cage is 1,300 diameter. You need to make one big, one small, one big, one small in your production. So you can come here and say, okay, I want to make this cage first, and then this cage second. You give it a name, and then you can make a production with multi. This we will go through it tomorrow. And then here in production selection, you have to select multi-program. Then you can see here, this is the multi-program name, and this is the program you are going to produce now. And then the machine will automatically switch. It will make one cage with 1,000 and one cage with 1,300 diameter. This is just a quick example, you can also say, okay, I need 3 cage from this and 2 cages from the other. So we will talk about it tomorrow.
Great,
But-
perfect.
Yeah, but this is just a quick thing. You can try some points what we mentioned today on the machine if you had time, especially for the welding point later and earlier, and when you change this parameter in the welding point start. So if you want, you can check here, take a picture, and when you change later and earlier, then you can see that this value here is changing. So just for you to get used to these things. And if you have also some questions or something about what we talked today, then you can also prepare your questions for tomorrow.
Please don't forget to send the tables via WhatsApp.
Yes, I will. Yes, and you want Andreas wants the password level 6. I will send it to you by WhatsApp also.
Thank you
Okay,
very much.
thank you very much, team, and we meet tomorrow.
Eli, thank you very much for your help and for your disposition to try to teach from a very long distance, and
Yeah.
the pupils try to understand you. I appreciate your time and your help.
You're welcome. Yeah.
Thank you very much, and thanks all for all the people that assist or attend to the teaching. Special thanks for Serapis. Thank you for your service.
Thank you all.
You're
Yes,
very welcome.
this is a pleasure for me to make it, and I'm happy to also speak to the people who are close to the machine. So now next time they want to speak to me, they know me personally, or I think a little bit.
Thank you very much, and see you all tomorrow.
Yeah, see you tomorrow.
Okay, bye bye.
Have a good day.
Hasta luego y gracias a
You
todos.
too. Gracias.
Hasta luego.
Hasta luego.